Hey guys, it's Bud, oh my god, and yes, I am here with another video. This video is all about mathematics. What type of mathematics? Well, let's get this out of here, and let's put some factors into here. Yes, those good old factors. And you may be wondering to yourself, what are factors, man? Tell us. Well, factors is a number that divides another number evenly. So let's use the number 12 as our example. As everyone knows, number 12 can be divided by 3 to equal 4. So, to make this into a proper factor form, we would do 4 times 3. And you may be wondering yourself, why is this 4 times 3? Shouldn't it just be 4 or something like that? No, because on this side it has imaginary 12. So if you said 12 equals 4, you would be incorrect. It's like saying 2 plus 2 equals 5. Or, here's another thing. Since it said it's a number that can divide another number evenly, you can also do 12 equals 6 times 2. Or 12 times 1. And you might be thinking to yourself, well, it doesn't change anything. Well, actually, you're right, it doesn't. But 12 divided by 1 still equals 12. So it is still considered a factor. And just to say evenly, remember this word, evenly. See, this pops up. Why I'm stressing evenly? Because you might be thinking, alright, 12 divided by 1.5 equals 8. 1.5 is not an even number, it's a 0.5. An even number would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are not even numbers, so therefore you cannot use these. So look, you can't do it. Even though it looks like you could do it, you still can't. Alright, now, common factors and factoring by grouping. You might be wondering, why did I just go through factors? Some of you may not know what factors are. That is the main thing. Well, the main reason why I did it. So let's go by an example 1 right here. And the example 1 we're doing is monomial common factors. So let's get 3x plus 18. Now let's do what we did in the last image and make this as low as we can get it to. Now, for us to get to as low as we can get it to, we have to get the highest number that can divide by both of these. So let's just quickly do this right here. We would have to put 3 here because that is what we're dividing all of these by. And if you're wondering, well, do I really have to? Not really. It depends. If your teacher wants you to put this in all the time, then put it in. If your teacher doesn't want you to put this in all the time and she just wants you to put, like, do it in your head, do it in your head. If she doesn't care and you can do it in your head, do it in your head. It's easy, simple. So we would just divide both of these by 3, and we would get the number 3 times x plus 6. Now remember, you always have to put the 3 in front of it to clarify this is equal to this. Because if you do distributive property, this would equal 3x, and this would equal 18. So let's go to our second example. And let's do this time with 2 variables. Now, let's get this to its lowest form we can get it to. So, alright, take your time right here. Like, pause the video and try to figure this out yourself. You did yet? Okay. It would be 2x. And you may be asking yourself here, well, aren't we only supposed to use 2's, 1's, 0's, and other things like actual numbers, not variables? Well, that is actually incorrect, because you can use variables as well. Sure, you could use numbers, so it'd be easier to understand in the last slide. But you can also use variables to divide as well. So we would get 2x divided by 2x, and we get 8x divided y divided by 2x. And you may be wondering yourself, how is this possible? It has a y. Well, remember, you don't have to have the exact variables when you're timesing or dividing. That is only when you are adding or subtracting, not when you're timesing and dividing. So keep that in mind, because the timesing and dividing not the same as adding and subtracting. So this, alright, guess what this would be? If you said 1, you are correct. And some of you may be wondering, but shouldn't it be an x like we did here? Remember, we have an x over here. And when we say x, we mean x to the exponent 1. And of course, everyone knows when you have x to the exponent 1 divided by x to the exponent 1, we say 1. And these are 2's. So if this was just x by itself, you would just put this as a 2 because we got rid of the x. But since this is 2x, we have to put a 1 because they're exactly the same. So since they're exactly the same, they can only go into each other one time. I know grade 5, grade 2, whatever grade you learn this in, but you have to remember that, and you always have to keep that in mind. And remember, since this variable is completely different from x, we don't take the y out as well, only the x, and we divide the 8 by 2. So let's go to our third example. And look at this, we have exponents. Oh no, how do we do this? Very, very, very simple. We just get the lowest, let's go in order. Get the lowest number. The lowest number in this case is 2. Okay, what next? Well, we have to find variables that can divide by both of these. So let's look at the lowest variable. The lowest variable in this one is a y. Is it also the lowest variable in here? Yep, because you can divide it you can divide y to the exponent 2 by y, and that would make it just y. Alright, what's the lowest exponent of x? Well, the lowest exponent of x is just x. It's like x1. So you would put 2xy as your answer here. And then you would just make them into shorter form, and you would get 2xy times 9x to exponent 2. Because remember, exponent 3 minus exponent 1, because it's divide, it makes exponent 2. And since we divided y by y, there is no y anymore because the exponent is now 0. Now, we just did the same thing to here, and we got this answer. Now, let us do this time with negatives. You may have noticed here we did it all with positives. You may be wondering yourself, what if I did negatives? Well, believe me or not, let's go with this example right here. What's the lowest number? 7. What's the lowest exponent of x? 3. Lowest exponent of pi is 4. And you always have the lowest exponent of a variable. And of course, it would be 7x 3, y 4, and you would just divide it all by that. And you'd be wondering, okay, but I still have the minus. But believe it or not, the minus can stay there. The minus doesn't matter at all, believe me or not. So just keep the minus there because it's the exact same whether you have negatives or positives. It doesn't matter. Now, here's the problem though. Binomial common factor. This is where it gets a bit scary, folks. So hold on to your seats. Oh, whoops. Let's not do that. Okay. We have 2y, and we have y minus 5. We have 5 times y minus 5. So what do we do with binomials? Oh man, I almost said bonomials. Either way, what do we do with them? Well, if your binomials are the same, then actually you would just put the 2y and replace one of the sides here, and then you would take the 5 and replace another sides here. And you may be wondering, what does that mean? Well, it means you literally put the 2y here, you put the 5 here. And if you're really wondering, is there a specific order to this? Well, yes. First here, which is 2y, and you go by this way. So if there was a 6 something, you would put like plus 6 something. So but you're probably wondering, well, what if these things equaled these ones? Like, what if the variable equaled the variable, and what if the number equaled the number? Well, it would look like this. But since it looks like this, y minus 5 times itself, you would put y minus 5 to the exponent 2. And it just makes it easier. And notice, these ones over here, they look like factored form. This one looks like vertex form. And you may be using that later in the future as we go with these videos. But, oh, whoops. Either way, I'll just show you this all right now. Alright, factoring by grouping. You might be looking at this and like, what? Okay, let's first look at my first example I gave up here. Alright, how would we do x, oh man, I burped, to the exponent 3 with y to the exponent 2 minus 5x for y plus 3y, well, you can see it for yourself. Well, actually, this is what we call grouping. So what would we do? We would get, we would basically cut this in half, and we put brackets around here, and brackets around here. And then after we do that, which is right here, we would get the lowest exponent of the variables as we could, which happened to be x3y. For this side. For this side, the lowest number and variable was just 3. So we divided this by 3, and we divided this by x3y. And remember, when you do factoring by grouping, you must try to get these two the same. And you might be wondering yourself, well, what if you can't? Well, if you can't get these two to the same amount, then you have to say that it's impossible. Because sometimes your teacher will give you a trick question like that on a test, saying, okay, give me a number that can, they'll give you something like this. Instead of putting a 5 here, like 15, they would give you something like 16. And if you do all the maths and you don't get these two numbers to be the same, because you have to try to get these two numbers to be the same, then you would say it is impossible, so it would be therefore it's impossible. And then and of course, as we did with binomials, since this is now a binomial because we put them into two separate brackets, we have to put the x3y here. And by the way, forget this 3 over here. This was a little accident of mine, so let me go fix that right now. Okay, I fixed it. I also realized that I put a negative 3 here, so I apologize for that as well. But either way, you would put this here, and you would put the 3 here. And even though this is a negative, you would still put positive 3. So that's the answer to this. And you may be wondering yourself, what if I have 6 numbers and variables? Well, you would do the same thing as here. You would just do it with 3 brackets instead of 2. And this is making it a trinomial. So we have to try to make all the trinomials equal each other. So we did it here, which we got 3x to the exponent 2 minus 3x. And we found the lowest numbers and variables here, which made it into x minus 1. And we did the same thing for each group to try to get to x minus 1. And if you can't get it to x minus 1, then it isn't. And by the way, if you can't get all of these to the same number, like the ones in the brackets, then it is impossible. You have to write, therefore, this defactoring by grouping is impossible. And then you have to put all these numbers like 3x here, 4y here, and then 4z here. And that's all you have to do. It's really simple. It's not hard at all. It just takes a bit of practice. But either way, hope you all had a wonderful day, wonderful night, wonderful everything. If you had any questions, comment down below and I will answer them. See you guys.